Enjoy the sight of the Milky Way while it lasts. Can you spot your city in this fantastic picture? Chances are you might be living in a very light-polluted area. For over 3 billion years, life on Earth has evolved in harmony with the natural cycles of light and darkness. The sun, moon, and stars have provided the sole sources of illumination, shaping the natural day-night pattern that has guided countless species. However, our modern cities have now become beacons of artificial light that overpower the darkness, disrupting this delicate balance and forever altering our environment. The consequences of this profound shift may initially seem intangible, but a mounting body of evidence demonstrates the tangible and wide-ranging negative impacts of our brightened night sky. Firstly, the health of human beings is at stake. Not only that, the ecosystem and wildlife are also suffering as a result of our illuminated cities. Additionally, our relentless illumination of the night sky poses a grave threat to stargazing and astronomical research. The Milky Way, a breathtaking spectacle that has inspired awe and wonder for millennia, may soon vanish from our skies if we fail to take action. Light pollution obscures our view of the cosmos, hindering not only our ability to appreciate the vastness of the universe, but also our scientific understanding of it. Darkest versus most polluted regions. The composite picture displayed at the beginning of this video was created using data collected by the Suomi National Polar Orbiting Partnership satellite. The satellite gathered this information over 9 days in April 2012 and 13 days in October of 2012. It required a total of 312 orbits and 2.5 terabytes of data to obtain a clear and comprehensive view of every portion of the Earth's land surface and islands. The image reveals that regions such as China, America, Japan, Europe, and Egypt, as well as the area between Qatar and Kuwait, emit the most intense brightness. Moscow was identified as the most light-polluted city in 2018, closely followed by Riyadh in Saudi Arabia and Montreal in Canada. Furthermore, it is evident that certain parts of the world have significantly lower levels of light pollution. These include regions in Australia, New Zealand, Africa, and South America. Nonetheless, it is important to consider that the satellite image only represents one perspective. It offers a view from space down onto the Earth's surface. However, there are substantial differences when observing from the ground towards the vastness of space. This raises the question of how the presence of light pollution impacts our surroundings. Although the picture provides insight into the extent of pollution, it fails to depict the effects on the ground level. These can lead to bad consequences. Montreal versus Aoraki Mackenzie Reserve. If you're not able to spot a single star in this picture, don't worry, it's not because you're blind. This picture of Montreal at night shows how light pollution can have a strong impact on the surroundings. Pictures like this serve as a stark reminder of the impact of light pollution on our surroundings. As humans continue to invent and innovate, most environmental pollution on Earth can be attributed to our own creations. From the automobile emissions contributing to climate change to the harmful plastics littering our oceans, our inventions have had far-reaching consequences. Among these inventions is the electric light bulb, often hailed as one of the greatest human achievements. While it has undoubtedly improved our lives by guiding us home and creating a cozy atmosphere, it has also brought about an unintended consequence: light pollution. The excessive artificial lighting in urban areas obscures our view of the night sky, making it difficult, if not impossible, to appreciate the beauty of the cosmos. Fortunately, there are still dark places in the world where the night sky remains untouched by light pollution. One such place is the Aoraki Mackenzie Dark Sky Reserve in New Zealand, the largest reserve of its kind in the Southern Hemisphere. Spanning the Aoraki Mount Cook National Park in the Mackenzie Basin, this reserve has been established to preserve the pristine dark skies that are free from light pollution. From this remote location, one could witness the breathtaking beauty of the Milky Way like never before. Moreover, being in the southern hemisphere allows for the observation of the Magellanic Clouds, two dwarf galaxies orbiting the Milky Way. Imagine being able to see two extragalactic objects at once with your own eyes, without the need for telescopes. Crazy, right? Some people say that if you have never seen the Milky Way from places like this, you've never really lived. In any case, how different is the sky in Montreal compared to the Aoraki Reserve? Is it possible to quantify the disparity? The answer is a resounding yes. Various measurements and scientific techniques can be employed to assess the levels of light pollution in different areas, allowing for a quantitative understanding of the contrast between the two skies. The most used method is based on the Bortle scale. The Bortle scale. The Bortle Dark Sky Scale is a numerical scale used to measure the brightness of the night sky and stars at a specific location. It assesses the visibility of celestial objects and the impact of light pollution and sky glow. Created by Johnny Bortle, it was published in 2001 to assist amateur astronomers in comparing the darkness of different observing sites. The scale ranges from Class 1, representing the darkest skies on Earth, to Class 9, which indicates inner-city skies. High ratings on the Bortle scale signify areas with significant light pollution, making them the worst for stargazing. A Class 9 city, for example, will have a brightly lit sky where constellations are barely visible, except for a few objects like the Moon, planets, and bright star clusters. Forget about the Milky Way. You won't even be able to dream of it. These conditions are common in the brightest cities worldwide. A Class 5 rating means that the Milky Way is faint or invisible near the horizon and appears washed out directly overhead. Light sources can be seen in most or all directions, and clouds will appear brighter than the sky. As you move down the scale from 5 to 1, the viewing experience becomes more impressive. For instance, the Aoraki Reserve is associated with a Class 2 rating on the Bortle scale. Here, the Andromeda Galaxy is easily visible to the naked eye, along with the Magellanic Clouds. The Milky Way appears stunning, and the Moon can even cast shadows during twilight. This offers a truly magnificent sight for observers. According to physicist Christopher Kaiba of the German Center for Geosciences, the phenomena of light pollution is rapidly causing the night sky to brighten, with an alarming annual increase of approximately 10%. This concerning trend poses a dire threat, as it could potentially wipe out the visibility of all but the brightest stars within a generation. For instance, a child currently born in an area where 250 stars can be observed at night would only have a diminished view of around 100 stars by the time they reach 18 years old. If these projections prove accurate, it is distressing to contemplate that the captivating sight of the Milky Way may become invisible to our eyes as soon as 2050. So enjoy its sight while it lasts. Hey, before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Effects on birds' migration patterns. Of course, in ancient times, humans used to light up their nights with fire. When we discovered electricity, things rapidly changed, and a lot of good things came with it. However, like carbon dioxide emissions and plastic, too much of a good thing has started to negatively impact the environment. Light pollution, the excessive or inappropriate use of outdoor artificial light, is affecting human health, wildlife behavior, and our ability to observe stars and other celestial objects. To start, light pollution can have a significant impact on birds' migration patterns. Birds use natural cues, including the position of stars and the moon, to navigate during their migrations. Artificial light can disrupt these natural cues, leading to a range of problems for migrating birds. Indeed, birds are often attracted to artificial light sources, particularly those that are bright and steady. This can lead them to circle the light source, becoming disoriented and wasting precious energy. Moreover, light pollution can obscure natural landscapes, making it difficult for them to recognize landmarks they use for navigation. This can result in them becoming lost and disoriented. Ultimately, artificial light can disrupt the normal behavior of birds during migration. For instance, birds may be more likely to feed at night under the influence of artificial light, which can disrupt their natural feeding and resting patterns. This is an interesting point because something similar happens to humans. Indeed, artificial light has a huge impact on our circadian rhythms. Ever heard of them? Effects on human health. To make it simple, human beings have internal biological clocks that regulate various physiological processes such as sleep-wake cycles, hormone production, body temperature, and cognitive function. These clocks, known as circadian rhythms, are synchronized with the 24-hour day-night cycle. However, electronic screens and LED lights have been found to disrupt these rhythms by suppressing the production of melatonin, a hormone essential for regulating sleep. To counteract this, it is advisable to avoid using phones after 7 p.m. to improve sleep quality. In addition to sleep disturbances, disrupted circadian rhythms can also lead to cognitive impairments. Memory, attention, and decision-making abilities can be negatively affected when these rhythms are not properly regulated. Furthermore, studies have demonstrated that chronic exposure to light pollution and the resulting disruptions in circadian rhythms can significantly increase the risk of various health problems. These include obesity, diabetes, cardiovascular disease, and certain types of cancer. It is crucial to understand that light pollution is not merely an issue of obstructing our view of the night sky. It has profound implications for our overall well-being. The negative impact of artificial light on our health should be taken seriously. By being mindful of our exposure to electronic screens, adjusting our habits, and prioritizing healthy sleep patterns, we can minimize the adverse effects of light pollution on our circadian rhythms and mitigate the associated health risks. Before we continue with what can we do, be sure to stay tuned afterwards if you haven't seen our earlier release on what is our place in the Milky Way. What can we do? So how can we make the world a darker place? The solution may be simpler than you realize. By taking small daily actions, we can minimize the negative effects of artificial light on our environment. For example, cities should consider installing motion sensor lights or timers for outdoor lighting, ensuring they are only active when necessary. They could also utilize shielded fixtures that direct light downwards, preventing it from dispersing into the sky or neighboring areas. Additionally, we should choose warmer amber-colored lights with lower color temperatures, around 2700 K, rather than cooler bluish lights. These kinds of lights are less disruptive to wildlife and are also better for stargazing. Lastly, it is important to be mindful of our indoor lighting usage. We can make a difference by turning off lights in unoccupied rooms or when natural light is sufficient. By taking these simple steps, we can contribute to creating a safer planet for everyone. So why not start today? What is our place in the Milky Way and our place in the universe? In ancient times, many people had the idea our planet Earth to be at the center of the universe, as stated by Aristotle and Ptolemaios in their Ptolemaic, Aristotelic concept of the universe. According to this model, Earth is at the center of the universe, and all the other celestial bodies orbit around it. Today, lots of people think the same, but is this really the case? To answer this question, let's try to travel in the universe through space and time. We will start our travel from our planet to reach, in the end, the extreme boundaries of the universe. During the 1600s, Galileo Galilei, the famous Italian astronomer, was one of the first people during modern age to have some doubts about the geocentric model of the universe. Thanks to telescopic observations, he was able to demonstrate our Earth is not at the rotation center of planets and the Sun, but really it is the Sun itself. Moreover, observing planet Jupiter, he discovered that the giant planet is the rotation center for its moons. So Galileo became aware that the center of the solar system was the Sun, not the Earth. The solar system is made by a star, the Sun, 8 planets, and different types of minor celestial bodies like comets, asteroids, and dwarf planets. Well, the Earth isn't at the center of the solar system. Maybe is the closest planet to our Sun. No, it isn't, because it is only the 3rd planet from the Sun. The closest planet to our star is Mercury, followed by Venus, and then Earth. The Earth moves around the Sun, our star, just like all the other celestial bodies in the solar system do. This implies that the Sun, and not our planet, is the center of rotation of the solar system. The Earth takes a year, 365 days to travel its orbit, and its average distance from the Sun is 150 million kilometers, which is the measure unit of distances in the solar system known as the astronomical unit, and abbreviated AU. Why do we talk about average distance? Because the orbit traveled by the Earth around the Sun is not circular but elliptical, and this means that there will be an aphelion, i.e. the point of the Earth's orbit farthest from the Sun, just over 1 AU away from it, and a perihelion, the point of Earth's orbit closest to the Sun, just under 1 AU. An alternative way to define the astronomical unit passes through the light time. In particular, we can say the average distance Earth-Sun is equal to about 8 light minutes. This means that sunlight takes 8 minutes to arrive on Earth, so that the sunlight we see at a certain moment is not that of that moment, but it is the sunlight which left from the Sun 8 minutes earlier. In other words, if the Sun went out, for example, at 2:30 p.m., we would only notice it at 2:38 p.m. Or again, if you could travel aboard the Star Wars Millennium Falcon, it would take you only 8 minutes to travel from the Sun to the Earth, when in reality it takes a few years. To give a more concrete idea of the dimensions of the solar system, if the Sun were a sphere with a diameter of 14 centimeters, Pluto would be at 700 meters from the Sun, like 7 regular soccer fields. The nearest celestial body to Earth is the Moon, our satellite. To reach it, you should take 3 days off. It's the same time taken by Apollo astronauts to cover the distance of nearly 400,000 kilometers that separate the Moon and Earth. But if you had Star Trek's Enterprise and travel at maximum curvature, you would only take less than 2 seconds to reach the Moon. Now let's begin to move towards the outer solar system. At a distance of 2 to 3 AU from the Sun, between the orbits of Mars and Jupiter, we would meet the asteroid's main belt. Asteroids are those small rocky bodies, whose dimensions span from a few kilometers to a few hundred kilometers. They are so small that they aren't visible through unaided eye, but only through telescopes. We could reach asteroids in a few years with a traditional spaceship or probe. Let's move on. We would need around 10 years and 40 AU to fly by Pluto, one of the outermost bodies of the solar system. Try to imagine it in your mind. If you were on Pluto's surface and had to look at our planet, you would only see a pale blue dot. That is the same sight captured in 1990 by Voyager 1 NASA probe, while it was leaving Neptune behind. Around Earth, only the dark vastness of the universe, barely illuminated by starlight. Now we have left behind our solar system, and we are going to enter the interstellar space. To get to Proxima Centauri, the closest star to Earth, we have to cover a bit more than 4 light years. We remember a light year is the distance covered by light in a year in the vacuum and is equal to about 10,000 billion kilometers. Distances begin to become big, since the Millennium Falcon would take more than 4 years, traveling at light speed to reach Proxima Centauri. And the Sun? Okay, it's at the center of the solar system, but it is also at the center of the Milky Way. If you continue to travel on board your beautiful spaceship, you will discover it. But it is a very, very long trip, so you will need much patience. The Milky Way is our galaxy. It is an immense group of stars held together by the force of gravity. It has the shape of a flattened disk with a bright core in the center, where the star density is very high, and spiral arms around it. Around the core, there is a spheroidal halo, which extends outside the galactic planet. At this point, it could be useful to introduce the parsec, equivalent to 3.26 light years, to measure the dimensions of our galaxy. So our Milky Way has a diameter of around 30,000 parsec, which are equivalent to 100,000 light years. So if we were back on the Millennium Falcon again and had to cross the Milky Way from one side to the other, traveling at the speed of light, the fastest thing there is, it would still take us 100,000 years to cross it all. Or to put it another way, if you were to send a WhatsApp message to your friends on the other side of the galaxy to decide what to do on the weekend, your message would take about 100,000 years to arrive. Assuming that your friends respond immediately to the message, the response would take another 100,000 years to get back to you. Keeping the same analogy seen before, with the Sun represented as a 14-centimeter diameter sphere, our Milky Way would have a dimension of 100 million kilometers. That is equivalent to make 2,497 turns of the Earth along the equator. The galactic halo has a diameter of the order of 30 kiloparsec and is populated by old stars that are stars with an age double that of the Sun. In the spiral arms, instead, there are younger stars, like the Sun, located within the arm of Orion, a secondary arm of the Milky Way between the arms of Perseus and Sagittarius. Our star, the Sun, is only one of the estimated 200 billion stars in the galaxy. Galaxy with capital initial letter because it is the galaxy par excellence. Our galaxy, in fact, its name derives from the Greek galaxias, the way of milk, referring to an ancient Greek myth for which the Milky Way would represent nothing other than the milk sprinkled out of the breast of the goddess Hera while nursing little Hercules. If it happened to you to find yourself on a mountainside during a clear summer night, looking up at the sky, you will certainly have noticed that whitish milky band that crosses the whole sky. It is the Milky Way. Since the Sun is inside one of the spiral arms of the Milky Way, from the Earth we see the galaxy as a streak precisely because we are looking at the galactic plane edge on and from inside it. It's like to try to observe all of our condominium from our flat. We will only see just our neighbor's flat, not the entire condominium because we are in it. But is the Sun at the center of the galaxy? No. Its distance from the galactic center is about 8,000 parsec, or if you prefer, 26,000 light years. Our star takes around 250 million years to go along its orbit around the galactic center. This means that since its formation, it's only made around 25 orbits around the center of our Milky Way, traveling at 215 kilometers per second. And it is good that the Sun is not in the center of the galaxy, because in it there is a supermassive black hole, Sagittarius A star, a monster with a mass equal to about 4.3 million times the solar mass and an immense gravitational field such that even light is not able to escape. This huge black hole is located in the direction of the constellation of Sagittarius, a constellation observable in the summer for the inhabitants of the northern hemisphere and in the winter for those in the southern hemisphere. Since a black hole does not emit light in the visible band, the same we see with our eyes, it is not visible directly through a telescope, but can be detected through indirect methods. Number 1, radiation emitted by the accretion disk around the black hole. A black hole is surrounded by an accretion disk made of matter that orbits spiraling around it. This matter sooner or later falls into the black hole. Before ending up in it, however, it is heated to very high temperatures of the order of 1,000,000 degrees, producing electromagnetic waves of very high energy, such as X-rays and gamma rays. Number 2, study of the orbits of the stars closest to the black hole. Studying the movement of the stars in the area of the galactic center, it was noted that they seemed to rotate around nothing, because apparently there was no visible celestial body in that area. Studies conducted by research groups led by astrophysicist Andrea Ghez and Reinhard Genzel, who won the 2020 Nobel Prize in Physics together with Roger Penrose, over the course of many years, have shown the existence of a celestial compact body at the center of our galaxy, right in the area where the black hole Sagittarius A star is located. And what about the Milky Way? Is it at the center of the universe? Even in this case, the answer is negative. The Milky Way belongs to the local group of galaxies, with a dimension of 10 million light years or 3.1 MPC megaparsec. We remember that 1 MPC is equal to 1 million PC, and that 1 PC equals to 3.26 light years. The local group includes more than 70 galaxies, most of them of small size. The center of mass of the local group is between the Milky Way and the Andromeda Galaxy, M31, and the local group, together with the Eridanus cluster, Fornax cluster, and Virgo clusters of galaxies, belong to the local supercluster with a diameter of around 100 million light years. It is thought that our universe contains around 200 billion galaxies, along with 200 billion stars. Can you imagine that with satellites, space probes, and telescopes we have explored so far, only a very little percentage of the universe? In conclusion, our Earth is not at the center of the galaxy, neither of the universe, but only a small planet around a small star which orbits in a peripheral zone of a spiral galaxy similar to many others. Citing Carl Sagan, is only a mote of dust suspended in a sunbeam.